Here for the 1x1 door, here's a half piston top, and here's one of the top modular line redstones. On top is just the construction paper with the cutout. I'm using the repeater from previous build. It was really easy to add the repeater since it was already fully done. I just had to make sure I was hooking it up correctly to the piston. When power is sent here, it'll go to the repeater circuit. It'll do a delay based on what it's set at. After the delay, it will send the signal over to this piston. The piston circuit here is the same as the piston redesign video. The only difference is in the code. Here's a code I suggest if you're trying to detect a voltage here instead of just detecting a ground potential as previous. The 2x1 had a linking arm, and so it was able to move both pistons at once. So popping off the torch top here was a power supply for the piston on the bottom using 3 AAA batteries. The bottom set of leads are supplying the power, the ground, and the VCC. And behind that main header is another header. It supplies a separate ground and a separate VCC in order to power the top torch here, as well as send a signal to the repeater here. Since the whole bottom circuit is being powered by the same battery source, the signal only requires a power being sent in since it's already grounded to the same power source. Alright, so here for the 3x1, I use the repeater in order to show that they're being powered by 2 different circuits. So now I'll pop in these covers here. When the photoresistor underneath the redstone dust circuit gets excited, it will send a signal. Here's a 4x1 and this top piston snapped on, as well as the dual rod here. So now looking at the piston circuit, there are 3 AAA batteries in this battery pack here, and it's connected to the microcontroller through this PCB. If it receives voltage in the back here, then it will extend, and if there's no voltage, then it will unextend. The battery pack comes completely off when disconnecting the lines, and also being able to disconnect the servo. Looking at the board itself, it's really simple. It just has an external clock since it's using the Atmega 328. On the underside is just a couple of the digital pins hooked up to these headers. There's ground leads and power leads going into these separate power headers and ground headers. From digital pin 2, there's a resistor. I think it's a 2000 ohm resistor. So if power is being supplied, then it can read the voltage here. And when there's no power being supplied, it will be pulled down to ground and the pin will read low. So for only being 2 pins, the pins do a really good job alone. But it still is enough to have some slop. These magnets I salvaged from some packaging. They work pretty good for connecting the pieces together. You can see there's no sag and it's pretty solid moving it around. In order to get it to be one uniform way, the magnet would have to have 2 separate poles on each face. Along with the separate poles, it would also need to be able to rotate within the block in order to align each other and finally click into place. In order to contain the magnets, a separate cage can be printed out and just slid into the box itself. There wouldn't be any issue with the magnets coming out of place since they're always going to be wanting to attract and not push out. Finally, in order to do the 2x2, I was powering this circuit separate from this circuit. And so for the left circuit, I was using the photoresistor and shining a light onto the photoresistor. For the right circuit, I was powering it using a separate power supply and just connecting the top signal lead in order for it to extend. The piston designs do have holes in order for pins to be put in. This allows for more blocks to be placed on top and for a signal to run through the piston here and accept that signal. The setup would end up looking like this, where there's a line of redstone here. You can power it on. Oops. And so you're using just quasi-conductivity in order to power the bottom pistons. I plan on using this design when I'm making the jeb door. I'll be working on the jeb door little by little because it requires 4 sets of pistons. The 4 sets will require 4 microcontroller circuits and 4 servos along with 8 printed pistons, and so that takes a long time. In order to make these builds easier, I do have a new solution. I'll soon have a different version where this extra block is put in front of the piston instead of behind the piston. This will reduce the amount of blocks needed and make it a lot easier to make the piston doors. Tape was used in order to hold the blocks together in order to act like a sticky piston. I also tried out using the magnets with the piston in order to make a sticky piston. I was able to get the block left behind just using the magnets, but also be able to attract the piston back just by varying the power supply to the servo. And also I had the magnets distanced away from each other in order to reduce the magnetic force. Applied a higher voltage to the servo, making it move faster. While it was supplied higher voltage, it would also retract faster, leaving the block behind. When I lowered the voltage, it would creep up to the block slower and then slowly pull it in. Instead of just varying the voltage, you can just vary the speed at which the servo moves. And so that's how I plan to make the magnetic sticky piston. Now the pins aren't too difficult to use. Usually when they get bent is when they cause problems. With the pins being vertical, I think it's going to be a lot easier to align them and even just get them to wiggle in correctly. So when inverting the signal, you can just flip the lever over, and that's an easy way of inverting. The problem with the lever is that when I designed it, it's not robust enough, and so sometimes it wouldn't actually turn it on correctly. On the other hand, the button is completely reliable. The problem is that there's no circuit inverting this signal, so when you press it, the torch powers on instead of powering off. When it comes to the pistons, you want to make sure that the shafts are extremely smooth, or else there will be too much friction, and so the servo will be overworked and won't be able to push out the piston. This has a little bit to do with how I have the servo set up. The main issue this happens is because I have the vectors pretty much maxed out. So when the servo is pushing, it's actually pushing at this vector here. Force will make the shaft rub here and most likely get caught. But since the surface is polished, there's really no friction and it's able to move the piston. I got really lucky with this design. Any angle lower or higher than how it is right here, the servo would have a lot of issues with trying to force it out since it's pushing at a steeper vector. If you're having issues with the piston head not being pushed out, then make sure you even polish up the paint. Right here I used 2000 grit wet or dry sandpaper and polished up the paint. So that's pretty much it. If you guys have any questions, please let me know. And thank you for watching.